Let's walk our way through the solutions to this comprehensive exam. First, as you know, the exam had 35 points. PE, if you see that anywhere on your exam, that means previous error. So if you made a mistake, say in this first problem, and you lost a sign somewhere, but then everything else was correct all the way to the end, then you would get a PE. If there are multiple errors, then you don't get that credit and you would have lost more points. Also notice over here on the side for this master, for both sides, it's got the worksheet number and the problem number from which this problem came, because all of these problems are directly from the worksheets. So let's look at the first one. Suppose the revenue in dollars are from selling clocks and they give you some function and the cost C dollars of selling clocks, and here's the function C. They want you to find P of X, which is the revenue minus the cost, so profit. What do you get? That's revenue. Take off what you have to pay out, that's cost, and that's what your profit is. So we have here, this is the revenue function, and then minus the cost function. The biggest issue that students had was not distributing this negative sign across. So you get negative 0.4x squared, negative 3x, and negative 200. This is part of that polynomial reminder we did in class the other week. You've got to distribute that negative sign across. And then here, finding the profit to the nearest cent means you are taking the 30 clocks and you substitute it into your equation. You did have to show that substitution and you get a negative number. So that means the profit is negative 635 when 30 clocks are sold, and yikes, you lost money. Find the domain of a given function. For this one, it's a fraction. So we are looking strictly here at the denominator for fractions. We know denominators cannot be equal to 0. So x plus 1 cannot be equal to 0. So x cannot be equal to negative 1. And that's exactly then what goes inside here for set notation. It is asking for set notation. You need the squiggly bars and then x such that that's the bar, and then you put the qualification inside. For the next problem, number 3, you have two functions and you are asked to subtract them from each other and then multiply them together. You'll notice this notation here. I recommend you put that. It's saying g minus f of 3, so g of 3 minus f of 3, and then go find g of 3, go find f of 3. For this problem, the biggest mistake was this negative sign not being distributed in. In other words, you wrote 3 squared minus 4 plus 3. Or sorry, 3 squared minus 4 minus 3. And so you forgot to distribute to the 3. So the answer is supposed to be 8. For this one with multiplication, it's saying take the function f of 0 and multiply it by g of 0. So here's f of 0 times g of 0. F of 0 means take this function and put a 0 in, 4 minus 0. G of 0, put a 0 into g, so 0 squared, and then multiply them together. Again, an issue here was not having these parentheses and then saying 4 minus 0 and getting 4. That's not what this is, it's multiplication. For the next problem, you had to put this into your calculator. We've done this a couple of times in class. The function you were using, you could either have typed this in or this part in to y1. Either one would have worked for you. It is written in the factored form because this is really telling us when y is 0, x is 0. When x is negative 1, you get 0 for y, and when x is 1, you get 0. So we know this is hitting here on this axis. So you have the curve drawn. You have to sketch with the arrows and then label those key points. F of 1 is asking you, what is the y value when x is 1? You could just substitute that in here and get 1 cubed minus 1. 1 minus 1 is 0. For negative 2, what's the y value when f is negative 2? So put it in for x up here, negative 2 cubed minus a negative 2, and you get negative 6. Now they're asking you for part B, f of 1/2, positive or negative. When we look at f of 1/2, we find 1/2 is sitting here, and f of 1/2 is the y value. So what's the y value when it's 1/2? Well, all of these y values are negative. So at positive 1/2 x, the y value is negative. What happens when you take that x value and make it a negative 1/2? It's saying, okay, over here at negative 1/2, what's the y value? Well, all of these y values in this interval are positive, so at negative 1/2 for x, the y value is positive. For what values of x is f of x equal to 0? In other words, what are the roots? What f of x is equal to 0 is when you have the x-axis here, all those y values are 0. What points are there? They happen at negative 1, at 0, and at 1. For what values of x is f of x greater than 0? So it's asking you, where are the y values positive? And that occurs here and here. And so what x values are that covered by those? Negative 1 to 0 and 1 to infinity. Sorry, moved it. Hold on, putting it back. And so the next question, so you have that one. Not going to let me, there you go, erase it. Okay. And so now, what is the domain of f? Domain, remember, are all values you can put into your function. So all x values. This function goes forever this direction and forever this direction. So all x's are covered, so it's all real numbers. What is the range of f? What are the y values that that function takes on? This goes forever to negative infinity, forever to positive infinity. So every single y value is assumed by this function, so the range is all real numbers. What are the x-intercepts of f? That's really the exact same question as part D, so you're looking for these 3 points. What is the y-intercept? Where does it hit the y-axis? It hits at this point, 0, 0. And I accept here either just a 0 or the point 0, 0. Keep going. How often does the line y equal x intersect the graph? So that line is going to come in this direction and come all the way up through. It's at a 45-degree angle, so it's going to hit here, here, and here. So it hits 3 times. You could also graph this, call this y2. So while this function is in the calculator, call this guy y2 and graph it, and you'll see that come right across here, and you count how many ways. How often does the line x equals 5 intersect the graph? Well, x equals 5 is a vertical line. So it's sitting out here and sitting way out here. And this curve is going to keep coming in this direction, and it's going to hit it once. Let's look at the next question. For what values of x does f of x equal 3? For this one, you are going to go into your calculator and say y2 equals 3 and graph that. And it will come across in a line like this. And then you're asked here, what is that x value for it to be 3? And it's going to be about 1.7. For what values of x does f of x equal negative 2? Do the same thing, call this guy y3 if you want. Graph a line down here, and then you'll find this point here for the x. Finally, this part of the question, find the average rate of change. The average rate of change formula is f of b minus f of a, minus sign, over b minus a. For us, a is 0, b is 1. So f of 1 minus f of 0 over 1 minus 0. 1 minus 0 is 1. F of 1, so take the function. Now this is the function that you've been working with for this problem up here. So what is f of 1? You get 1 cubed minus 1, which is 0. This is this little 0 sitting here, minus f of 0. So put the 0 up in this function. 0 cubed minus 0 is 0. So you get 0 minus 0. 0 minus 0 is 0. 0 over 1 is equal to 0. So that answer is 0. Let's look at the next page. This problem at the top, again, is directly from one of the worksheets. I did throw it out. In other words, it was not counted for the exam. I highly recommend you go back and look at your worksheet and any notes that you took. You are looking at the total amount of receipts that they give you. You really should write it in English. So you have the total money is the number of adult tickets times how much you charge for the adult tickets. plus the number of children that are going for the tickets that are sold times how much it costs for each child. And you substitute those in. Multiple times we've used this technique. You know we have 3,900 tickets, adult and children. You don't know how many of each. So you solve it for one of the variables and you substitute it in. Then this is just the algebra you're going to work through, and you get about 1783.3. You need a whole person, so we have 783 children. For the motorboat, we have a current of 3 miles per hour upstream. Remember, the boat is got a certain speed that it is set at, and when you're going upstream, the current is pushing it backwards. So whatever rate the boat is going, and we don't know that, we subtract the current. When you're heading downstream, it's pushing you along, so whatever rate you're going plus then the rate of the current. They tell you the times and you fill those in. You have got to multiply across these columns to get then that far left. So time times rate is equal to the distance, and you have to multiply across to fill in this column. It's okay to expand it, or you can leave it in parentheses. For this one, all you had to do was set up the equation, assume the motorboat assumes this constant speed, that's that rate, you complete the chart, set up your equation. How are you going to do it? Well, we know the boat leaves and goes to wherever they're having their picnic, get out, have their picnic, and come back. The distance is the same, so you just set those distances here the same. So they're going to be equal to each other. For the next one, this is the working together problem. We've got 2 people. They are delivering newspapers, and it's in minutes, so the job is in minutes. It takes Trent 30 minutes, Lois 20. We don't know how fast they work together. How much gets done in a single minute? Well, if it takes him 30 minutes to do the whole thing, he gets 1/30th done a minute. So 1/30th, 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 until for 30 minutes he's been working at that rate. So 30 times 1/30 gets 1. That's the whole job is done then. Now we have their rates for how fast they're working, and however fast he works a minute plus however fast Lois works a minute gives you however much they're working each minute. That is our equation. You have to have the LCD as 60x, multiply that, divide out common factors to get then 2x plus 3x equals 60, and get down to then 12. You do, when you have a word problem, you do have to have a sentence answer, so it will take 12 minutes to do that job together. For the next problem, all you had to do was set up the equation. You've got quantity, supply, and demand. We talked about equilibrium points, and that's when supply equals demand, and so all you had to do was set supply equal to demand, so set these two equal to each other, and that then would allow you to find the equilibrium point. For the last problem, we have a tennis court. We know how much the area is. We write that inside here. And it is 6 feet longer than twice its width. So we don't know the width, call it W, but we know the length is 2 times that width plus 6. Area then is length times width, so you multiply them together to get 308, and you do not have to solve it. If you still have questions about this exam or anything on yours or anything about the grading, all you have to do is come and see me. Hope you're having a great day.